CubeSats, the next generation of small satellite technology designed by engineering students and industry partners from all around the world. Will these nanosatellites change the future of space research? Does Blair have the right stuff to get his CubeSat off the ground? Find out next on NASA Edge.
Welcome to NASA Edge.
We're here at the 10th Annual CubeSat Development Workshop in San Luis Obispo,
On the beautiful campus of Cal Poly. And we are joined by industry insider and friend of the show, Tiffany Nail.
Thank you. It's great to be here, Franklin.
It really is great to have you, and the good news is she's just completed my 10-week course on how to host a show, so I think you're ready.
All right, can I start over? I have a little anxiety, but I'm up for a challenge, so I say let's do this.
Well, I tell you, while you get in the zone, Franklin and I have an opportunity to talk to two of the founding fathers, if you will, of the CubeSat workshop world. Let's take a look. As I understand it, you've been involved with CubeSats since the beginning with Dr. P.
Yes. In 1995, I got an opportunity to go to Stanford University to start a small satellite program. My goal at that point was to build a satellite within at least 2 years, because most of the students that worked with me at Stanford were master's degree students, and some of them stayed about 2 years to get their master's degree. Well, you know, come 3 years, we still didn't have it built, and we'd actually started the second generation of that satellite. And it took me until almost 2000 to get the first one launched. And it was an interesting satellite in that we had collaborated with the Aerospace Corporation, and they had this idea for little what they call pico satellites. And they wanted to launch them and see if they'd worked. And so we actually built some launchers in them that would hold these pico satellites. And the pico satellite shape at that time was like a Klondike ice cream bar. Okay.
Wow.
And we built this thing and we got it up and we actually got these little satellites launched.
So you mean to tell me, like the original, like before the P-Pod, you actually launched small satellites from a satellite?
That's right, yeah. So it was a mother satellite with, you know, we called them daughters that were in it.
That's awesome.
And that was how it launched, and we developed this launcher to do that. Well, you know, I got to thinking about this, and one of my problems was I couldn't get the students to build the satellite fast enough because I wanted them to go through the whole process. I wanted them to say, we want a satellite to do this, this is what we have to do. These are the trade studies we got. This is our base design. Let's design it. My objective was to get through that in a 1-year period.
Wow.
Of course, that didn't work. You know, the more room you got, the more stuff that they put in them.
Yeah.
And I got to thinking about that. I said, you know, maybe if I make this thing small enough, they can't keep putting more things in it. So let's restrict the size. And I knew that in order to get them launched, the smaller you can make them, the better off you would be. So I started looking around for something that was small, but I knew I had to have a cube because we were not stabilizing these things, and I needed to put solar cells on all 6 sides. And at a plastic shop, I found a 4-inch Beanie Baby box, okay? So I took that.
This is a story of CubeSat we haven't heard before. Not many people have been talking about the Beanie Baby origins of CubeSat.
That's right, but that's the way it started. You know, it wasn't this magnificent calculation or anything that we did. It was a matter of size and components and convenience.
It's just interesting to me that all this development sort of took place on the fly. You know, you were
Yeah.
kind of developing as you went.
Mm-hmm.
Good grief, we're now 10 years into the workshop program,
Mm-hmm.
and it's almost its own industry.
Yeah.
How does it feel from your standpoint, knowing that, you know, this sort of was born out of all that work that you did?
Dumbfounded. No idea that it would ever be like this.
What do you think of the CubeSat industry as it stands now?
If you look at the rate of innovation, and we kind of predicted this at the beginning, we thought, well, because of the students are coming in, and the students are so innovative at this age, and they don't have all the restrictions you get. You know, you got out of school and you went to work for somebody and you said, well, I got this great idea. And this older engineers said, oh, I did that 10 years ago or 15 years ago and it didn't work. But you know, the materials have changed, the technology's changed. And so, you know, you cowered down and said, okay, well, I won't try that. But what we try and teach our students now is, look, when somebody says that to you, we want you to jump up on the desk and say, damn it, things have changed now, sir. No, but be forceful, because you have had in these programs some tremendous experience. And we had our students go out and they would immediately make them system engineers because of their broad background. And it would scare the bejeebers out of them. But in reality, you know, it took 20 or 25 years for somebody to become a system engineer, because you always started out as a specialist. And you see there is something about building something that goes into space that sparks these students. They're in this big cloud for a little while, and all of a sudden they kind of break out of this cloud, and the self-confidence and the enthusiasm just builds, and you better get out of the way because they're going to run right over the top of you.
Professor Twiggs is absolutely correct about how students really push the development of the technology. Let's check in with our special guest host, Tiffany, and see if she's ready to push the development of her interview skills as she and Franklin talk to the students here at the workshop.
Hey there, I'm here with Travis. How's it going?
Pretty good, and yourself?
I'm doing good. Now, tell me, you're here connected to a CubeSat. What is your CubeSat name? And then also, what do you guys hope to accomplish with this CubeSat?
We're from the University of Louisiana, and our CubeSat is called CAPE 2. We have previously launched CAPE 1 in 2007, and CAPE stands for Cajun Advanced Pico Satellite Experiment. One of our main missions for this next satellite launch is an educational mission. We're trying to get kids more involved. So one of the technologies on our satellite is a parrot repeater. When the satellite is overhead specific areas, kids can chime in and type something, and it'll send back actual voice of what they typed in.
This is the communication subsystem bus 1000.
Also, they're able to get information from the satellite, like temperatures and other things like that. It's very important to get kids involved early, you know, because we need to kind of fill the pipeline, right?
First of all, tell me about PhoneSat.
So PhoneSat is a technology demonstration. We're saying, you know, how cheaply can you actually build a satellite? And one of the great things about a phone is that it has so much in it. And there are 6 billion people around the world paying for the development, so it's really cheap. So you have this phone that has an extraordinarily fast processor. It's got sensors, it's got magnetometers and gyros and a camera, and they're built to withstand people throwing them against the wall, and so they can survive the launch environment.
So basically what we're talking about, PhoneSat, and yes, this is exactly what this is. It's just basically a phone that you guys bought off the shelf. You put it into a cube, and then you put it on a rocket, and just recently, I believe, it launched. What day was that?
It was a few days ago, Sunday, actually. So we launched from Antares, and actually they're flying around our head right now.
Oh, excellent. So we're going to hear from PhoneSat soon then, is what you're saying.
Yeah, exactly. In a few minutes, it should pass behind the mountains. So hopefully we should hear from it.
Do you ever kind of like share with other teams that have a CubeSat? Do you guys like share, or is it a competition? Tell me, what's the inside scoop?
Surprisingly, it's very collaborative. CubeSats that are similar to each other, they're eager to help you. You know, talk about, oh, I use this camera, I use this, you know, this board, that board. This is how I lay my solar cells. It's a really great community, and we're all trying to get launched. Everyone's trying to get launched, so we're all really, excited to help each other out.
So we've talked to a number of students here who are working on their first CubeSat. You've actually had CubeSat success with the students at Montana State. Tell us a little bit about the significance of your launch.
So in 2011, we launched a CubeSat called Explorer 1 Prime. This CubeSat was a reflight of the first satellite ever launched by the United States, Explorer 1. What it was a Geiger tube that actually discovered the Van Allen radiation belts. What we did was we took that technology and we packaged it up into a CubeSat and launched basically the same experiment. And it gives you to showcase where technology has come since 1958 when we launched the first satellite of the U.S.
How many times have you been here, and what do you expect to get out of this year's?
This is the 5th year I've been here, and it's really nice because the CubeSat community is fairly small and tight. So now that's the 5th year I've been here. I know a lot of people. You know, we could talk about what they're working on. You can kind of see where other people are going, kind of where the technology is being pushed. And one of the cool things, our first satellite was on Alana, which was the first national launch. So we were talking about single launches, and it's grown so much that, you know, there's dozens of individual CubeSats going out, which is really, really cool to see in just that short amount of time.
Now, what kind of enjoyment or sense of fulfillment do your students get when they are working on the CubeSats?
Well, you see students that are really engaged by applying what they learn in the classroom in our laboratory. So we're not reteaching them what they learn in class. They're actually using what they learn in class and applying it to actually build something real. When that satellite is launched, that enjoyment is compounded because now you've got something that you can hear and talk to in space. You can actually see your measurements at work, and then when the data comes back, the students are really excited because they get a huge sense of fulfillment, and it helps them go along in their career and have the self-confidence to know that they can do a great number of things using just the knowledge that they have.
Tiffany also had a chance to talk to John Garvey about the development of his exclusive nanosatellite launch vehicle.
So explain to me Garvey Spacecraft Corporation. How did this come about? What inspired you to come up with the corporation?
Well, I was working for a big aerospace company, working on big rockets, and decided it would be easier or more fun or more efficient, whatever the right words are, all of the above, to try to do those on my own. So initially we started building test vehicles for technology demonstration. And around 2003, we realized that this market for CubeSats really needed a dedicated launch capability if it was going to reach its full potential. Our long-term goal is to develop a dedicated, responsive, low-cost nanosat launcher, because right now, the primary option for getting to orbit is still as a secondary payload on a much larger vehicle. And that's a good way to start, but there are a number of limitations for many users, particularly commercial or operational users. You know, you don't control your schedule. You have to live with the constraints of the primary payload user, and these are very rational. But if you have your own vehicle, then you control your destiny more. So we've been trying to work on these programs to quantify, let's say, the cost, get the processes down so that when we do get to the operational missions, we've already pathfinded a lot of those and hopefully reduce the risks on the administrative and programmatic side as well as the technical. And along the way, we also had a lot of students involved, so we were able to continue bringing in that next generation. One thing that's key in all this is when we're working with students is you always have to be recruiting for that next group. And what we have found is field testing. When you go out in the desert, we fly at a nonprofitly owned site that's outside the town of Mojave. That's a good filter, because the students go out there and some determine they don't like the field. They'd rather be in a lab or behind a desk crunching numbers, which is totally fine. And there's some people who find out they love it. They love going out and working with the hardware and getting their hands dirty. And those are the people we're looking for, and we try to then recruit them and teach them the right way to work. And again, if they continue to show promise, then we try to bring them into the team.
Now college and high school students are getting even more involved in nanosatellites and launch vehicles. The workshop has come a long way since 2003. Franklin talks with Dr. P about how it's developed.
Jordy, this is the 10th year of the CubeSat workshop and the 10th year since the first launch of a CubeSat. How has the program evolved since then?
The first workshop was a really small event. We just wanted to bring the few people that were working on CubeSats together. Our first launch was coming up in Russia. So it was a very small affair and very informal. It was just kind of a get-together to try to figure out how to move forward. Now we have hundreds of people here from government, industry, universities, students, technical people, program managers. We have almost anybody. And it's a much bigger event. And it also is very different in the tone. Initially, it was all an exploratory event where we were trying to figure out what are we going to do. Now is people telling us what they're doing already. And also talking about what we're going to do, but with a lot more certainty that we're doing things that are going to be important. We have missions coming up. We have projects that we're proposing to NASA, to DOD, to NSF. But it's also maintained that small community atmosphere. Everybody's interested in the same thing. And we have a really strong educational presence. Lots of students, lots of academia, teachers learning about CubeSats, and many of them are starting their own program right now. So they're here to learn how to move forward, and hopefully being here helps them speed up that process.
To date, how many successful CubeSat missions have flown?
There is probably around 100 CubeSats that have launched, and the number of missions is probably getting to the dozens because they're launching in the US, but there's also launches happening other places. It's getting to the point where almost every launch has the option of carrying CubeSats if they have the space. And then of course we're launching from the space station with NASA support, and that's another interesting change that now we're even launching from orbit. So it's everywhere, and the numbers are hard to keep up with anymore because it's just happening all the time.
I guess that's a good thing.
It is a good thing.
10 years down, what do you see for the next 5 to 10 years from the CubeSat
It's
workshop?
actually very interesting because if you had asked me that question 10 years ago, I would have failed miserably at predicting what has happened. Nobody expected we would be where we are. So I'm reluctant to say what's going to happen in 10 years because I'll probably miss, and you'll show me the video later and say you were wrong. But I think the fact that we're doing missions is the biggest change. And I think there is things like 6U deployers and bigger satellites that are using the same CubeSat model as far as the components they're using, the standardization. And I see those two things as the keys. There's going to be more missions, and that's already the case, but it's going to continue. We'll probably go to constellations pretty soon where large numbers of satellites will work together. And then we'll use the lessons learned from CubeSat in bigger platforms that will provide a faster development time, lower cost, more performance. And then there'll be a bunch of things that I have no idea will happen that will surprise all of us. But that's the beauty of the future.
CubeSat technology and the workshop are a huge success, and we were able to talk to Jason Cruzen from NASA Goddard Space Flight Center about how both students and NASA gained by developing nanosat missions.
So several years ago we started our CubeSat launch initiative, mainly as a recognition that there was a lot of student groups out there building CubeSats that didn't have a way to get to orbit. But really, where our big push lately is how do we utilize CubeSats to actually do technology development, risk reduction on various communication systems, networking protocols, understanding biology in a very cost-effective way.
And have we gotten any results has there been any actual feedback from a CubeSat mission?
Yeah, what's interesting is some of these CubeSats that were just technology demonstrations at the beginning are actually getting real science data as well. Some of the ones that the National Science Foundation has funded and then we've actually flown to space have now actually had peer-reviewed science being published on their outcomes, which is a secondary benefit of it. You're seeing next-generation communication systems starting to be developed in a lot of these CubeSats, and I think we're right at the cusp of seeing large-scale usage of CubeSats even by the commercial industry. We always kind of wondered where the plateau for how many CubeSats could be built by the community that's out there. And we always say, well, this is going to be the year that we kind of plateau out and we won't get that many more proposals for launch. But that plateau still hasn't hit yet. So you got this general increase of utilization of low Earth orbit and the more common orbits that we get. With that experience, though, they're building higher and higher reliability spacecraft. A lot of student groups will start out with what I refer to as like a beeper sat. I mean, it's a little simple satellite. It gives off a small comm signal. They can track it, but it actually doesn't really have many functions beyond the building of it itself.
You just get a sense of accomplishment.
You get a sense of accomplishment with it. But they quickly move on from that to real technology and science-based CubeSats. So you're seeing them advance very quickly in 1 or 2 build cycles. So I see them going and utilizing low Earth orbit even more, but then where do we go after that? Once we get the reliability, we get these more complex communication systems, can we go somewhere else with them? When we go to an asteroid or we go to Mars, can we take CubeSats with us? Can you imagine that we're up getting ready to dock with an asteroid and the crew vehicle is coming up and we pop off a CubeSat, and then the CubeSat is the camera angle. It is the wide angle lens of seeing a crewed mission coming into Mars, into orbit, or a crewed mission going to an asteroid for the first time and seeing that kind of God's eye view, camera view. So to me, there's a lot of robotic precursor missions. There's a lot of knowledge that we need to know about the environment that we're going to before we step the crew in there. The lowest cost way to do that may be through some smaller satellites to actually do those measurements. I see it synergistically. So if you advance a comm system in a CubeSat, that comm system, could it be the comm system that's part of your EVA suit? It's the same kind of form fit. You need low power, low mass, high reliability. Can you put it inside of a suit? Can you put it inside of a telerobotics platform? But when you boil down things to lower level components, they're actually all the same. So avionics on a CubeSat could be avionics on your robotic lander. What if we're on the planetary surface and we have a whole sensor web sitting around the surface? How do all those sensors talk to each other and communicate back through? You can think about it as a swarm of CubeSats. They just happen to be on the surface. Through advancing CubeSats, are we actually advancing our next generation satellite networks and sensor networks that we'll even use on surface systems? So it would be, to me, it's pretty exciting.
Speaking of advanced technology, a few months ago I pitched my nanosat concept, MagnetoStar 1, to Garrett Scrobot and his colleagues at NASA. After making a few tweaks, it is time to test the collaborative nature of the workshop and see if I can get some constructive feedback for my uniquely designed CubeSat.
So this is a CubeSat?
Yes.
Are there electronics in here?
It's proprietary. I'm not allowed to talk about what's inside the box there, but that's the brains of the. That's the
brains. Yeah, held together with duct tape.
Everybody's usually really fond of duct tape.
I mean, yeah, Apollo 13 fixed their issues with duct tape, so why couldn't this satellite?
And what do you think of this way cool communications array? Is that not impressive?
I wonder if that will actually deploy in space. It looks like you kind of had to pull it open with your hands, so you're not going to be able to do that in orbit.
I don't know. Have you weighed this?
No.
Does it pass the mass budget?
No, I
see power budgets, mass budgets. What is this deployable? Is it going to stow during launch? Or got a lot of deployables here.
Nick, you have a lot of questions.
So many questions.
Now, in your professional opinion, because I really value what you say, what are my chances of seeing MagnetoStar 1 fly?
In space?
Yeah.
Yes. Have you seen the P-pod and do a fit check?
I was going to check that out actually soon.
Yeah, I think my guys can help you maybe do some fit checks and see if we're off a little bit or a little bit more.
Okay, okay.
I'm still stuck on the fact that it's made out of duct tape.
No, that's not. It looks like duct tape, but it's special space tape.
Oh, right. It's Kapton tape.
What's Kapton tape?
Maybe you shouldn't be building the satellite.
And what about, does this outgas? You got to worry about that.
Wow, I hadn't thought of.
Have you even had a mission readiness review?
All right, we're done here with the advice. Clearly, I'm going to have to re-enroll in enroll in Cal Poly and get some hardcore time in the lab.
That sounds right.
You know, even our prototypes start really simple because what we want to do is we want to get something that's simple and we can do quickly to test it so that we don't start chasing something. So even some of the prototypes that we've done on our satellites, we try to build something, even if it's not the most glamorous looking, we try to get it so quick so that you can know if you're going down the right trail.
I want to know if I'm reading you right. So you're suggesting this is glamorous looking?
No, well, I'm saying it's got a little work to go, but to sustain those launch environments, which are pretty gnarly.
Can somebody help me shake test this? Okay, good. Turn it off, turn it off. Well, in addition to learning an awful lot about CubeSats, I gotta say, I really believe MagnetoStar 1 was very well received today.
And you know who else was well received? Our special guest host, Tiffany Nell. Tiffany did an excellent job, and we enjoyed having you on the show.
Thank you, Franklin. Thank you, Blair. I appreciate it. I had a lot of fun.
It was great. And I tell you what, if we ever come down to a CubeSat launch, would you be willing to host the show again?
I would be honored.
Awesome. Well, you tell you what, in addition to getting Tiffany, we probably ought to get the entire CubeSat student body to come down and help because they were a tremendous help today. And we wanted to give a special thanks to them. You're watching NASA Edge.
An inside and outside look at all things NASA.